Okay, we'll continue from where we left off. So we did the floors. I've been switching buildings to see if it's been working, and it seems to be working fine. So far so good. So I'm just gonna make sure that this is lined up, bring it down here. Let's name it floors. Floors. One thing that I like to be aware while I'm working is the dependencies to see if nodes and attributes are locked in other places, linked. Sorry, and in order for us to visualize that, there's a guy here. Where are you? View show for selected nodes. So which means that if you select and if there's a reference, it throws this line, which is very, very useful. It goes there, and goes there, and goes there. So now what we want to do is to break the shapes a bit more so it's a bit more interesting and create some paneling, etc. So we will start by creating by first isolating all the flat areas. Okay, so for that I'm just gonna put a delete sub here, and we're gonna delete by normal. So delete selected, primitives, normal, enable on Y, so that's like 100 degrees, and that should, we'll bring this from here, and that should give us all the flat areas. And let's just cross check that by enabling this. Okay, it's not all, but it's most. Let's get more. Maybe we can play with the settings a bit more. Okay, so what if I go like this? Doesn't matter. Okay, well, it's either way works. Okay, so it's just that we got the base ones pretty much, and then what I want to do now is to actually remove any if there was any floors. Trying to find one to tell you what I mean. I don't see it at the moment. Like if there was any intersecting faces or something similar to clean up inside, it's the, maybe this one here. No, seems like this is just a lucky batch. Okay, well, I'll give an example because it's not the same number, I guess. Do we still have the same buildings? Let's check what number is this. 0. Let's switch to 0 then. So I will have probably the same settings, same output than what I have, but no, this is random. Okay. Again, anyway, we'll continue. So, and I'll show you what it does as well. So we're gonna put a divide. Okay. And remove shared faces. So that kind of just cleans up what's inside. I mean, I guess I can show it like this as well. If I put a grid, if I take a divide again, so if you just want to get the edges, that's something you can do, and you get pretty much just the walls edges. So that's what it's doing, just because I'm going to extrude these and I don't want anything like, it's just, we're just trying to work with the minimal amount of polygon as much as we can. So but I need the edges anyway, so I'm gonna put ends here now. So this is going to remove the inside faces. Okay, so unroll with new points on the first option. Now we have all the basically the borders of this geometry, and now we're gonna scatter points. And now I'm scattering on 100. Okay, so just 100 points. Basically, I just scattered points on the edges of all the faces that are pointing up. So we're gonna do another copy now. So and you'll see where I'm getting now by doing this. Let's put a box. Let's call it outer walls, and then null out sizes. And we're gonna do a copy. So let's do it for each point, just like what we did before. Goes in here. We're gonna need a null here. Call it randomize. Okay, and then copy to points. Copy to points here. So that goes there, that goes there, that goes there. So I want to fetch some attributes and create a random attribute based on some expressions, okay? This is just another way of doing what we did here. Here we had an attribute coming in. Now I'm just gonna put an expression because we're just doing things a different way, just to see how things work. So it's gonna be a fixed size for the copy swap for the height, I believe. Is this what we're doing here? Yes. So size X, size Y. Okay. So this is kind of like a stamping now. We're gonna pass information from here, randomize to out sizes, and from out sizes to outer walls. Okay, so it's literally like instead of doing the randomization here, we're doing it there. So for my outer wall size, I go 400 in size. Okay, so we get this, and I'm gonna leave the silhouette open as as a template. So I'm like skewing the building like a kebab, and then I'm gonna create two attributes here. They're gonna be integers. So what we can do is that we can say integer, where is it? Copy this guy here, 2, so it's 2 floats. Let's give it a name called size. Okay, and then apply, accept. So now we're gonna type, I'm just gonna copy this and I'm gonna explain it. So actually I'll explain this one, and then I'm gonna write it on for the other side. So what we're doing now here is I'm saying give me a random value based on the position of the processed point. So for this turn, it's this guy, and see it also made up the connection already, and then fit that from, because the random value based on an attribute is going to return 0 to 1, and then I'm saying fit that into between 5 and 10, and then if there is any attribute coming out like 5.5, it's going to floor it, or 6.5 in this case, it's going to floor it to 6. Now I'm just gonna exactly do the same thing here, but this time, for example, the X component of the position is creating the attribute here, and then in the second one it's gonna be the Y component. 0, 1, 2, right? Yes, so 0, 1, 2 is It's the same, I think. It just gives a different number. Okay. So then I'm gonna change. Well, I could have literally actually put the numbers here, but I think maybe I want to do something with that to maybe create a little UI so it's easier. But eventually what I did in my scene was I literally just copy this output to here, and I'm gonna do the same for Z, which is gonna go here. So now if I process this, and this should have, did not work. I'm missing something. Yes, copy, yes. Interesting. It didn't change the size. Why not? 6, 8, 6, 8. Okay, 1 second, maybe like this. This doesn't matter. But for every point it should be different. So I have 100 points. Was 100? Yes, and each one of them is going to have a different px, py, and this is the value I'm fetching here to generate random values. So if I go single pass, these values should change every now and then. Let's block this. Yeah, so it is working. So why it's not? Maybe it is working. It's just that not exaggerated as much as I thought it would be. Oh, okay. So maybe we can cross-check it like this. But they do all feel. Do they? Let's have a top layer. No, they're different. Okay, so our threshold was just too small then. That's fine. So let's go back to the perspective view, and then if there's an intersection happening, which there is, so we do want to clear that up as well. So we do another boolean, and then say intersect. Everything is solid. It's fine. So if there's an intersection like this, now if you look inside, it's open. I think it's empty, which is fine. Okay, so now what we want is another boolean, because right now what we have is a lot bigger than our building's boundaries. So we are gonna do another boolean from inside removed faces. Come here, and it's gonna go to the left, it's gonna go to the right, and it's gonna give us the intersecting sections, and that's why we're gonna start building little windows, maybe like walls or panels, just to break up the shape a little bit more. It's intersect solid. Yeah, that's good. And then I just want to extrude that a little bit so it gets out of the buildings. So I'll go poly extrude. So our number could be like 1 meter. So it just gets inflated pretty much. So it just actually gets out of the doors. And then one more boolean to get a shell out. So the boolean tool is very impressive. I think it does an amazing job. We will create this one here. It's gonna be subtract from A to B, subtract, and then this is going again to the beginning. Boolean. Okay, so now we have some pretty much shells. That looks interesting. And then we're gonna I think this is where we are supposed to, yes, you remember the this null we left over here? So we now that's where we left it over, because that's where we want to replace that with a boolean. Here, and that's also subtract now. It's just so we can cut our grounds as well. Oh, I think we need to do that before Boolean. I'm gonna pause the video. Okay, so we're back. We were chopping this, right? It's after extrude. Okay, so not from there, but from there. And now we cut some of those chunks out as well, what we have here. So it's a bit more interesting. It's just breaking the silhouette. Okay. So what I want here is that, is it this guy? Yes, I want to be able to have access to all these groups, because when we use Boolean, we can actually generate some groups. So if I may show you using a blast, because we want to get rid of some of the parts, like no overlap. Okay, no, let's delete this one. No, okay, maybe this. Yeah, so like we can keep some parts. So right now it's cutting from there. If I remove that, it's the opposite. So what we want to remove is B inside A. B inside A. So remove that. So I'm just keeping one face, pretty much. Then I'm gonna create a normal, because we're gonna make something a bit more interesting out of this. I'm gonna create a measure sub. Do we need the normals? Oh, normals can stay on vertices, yeah. And we're gonna need a measure sub. That's a bug. It gets stuck. Okay, normal. Okay, put down a measure sub. Leave it as it is. I think it's yes, area per element. Yeah, the default. So it's gonna give us some values here, and we want to, just like before, we want to get rid of some of the areas that have a certain bigger than a certain value. So I'm gonna put it into wrangle, and if that area is bigger than 100, then remove primitive, remove prim, 0, add prim num, and the points as well. This needs to run over primitives. I think you can exact close parentheses. I believe they can do the exact same thing with a delete sub. It's just that I don't use it really. Delete, I think you can just say at area. Can you do that? Well, apparently you can, yeah. See? Oh no, this is returning some of the value. Okay, maybe blast. Okay, so well, so we can use that as well, but it's the same thing really. It's area, as long as it returns the same result, which it doesn't. Okay, so then we're gonna stick to this and we'll investigate that after. Okay, so these are some panels that we want to process, make them look a bit more interesting. So we're gonna achieve that by actually cutting each one of these many times from certain angles. And this is, maybe this value is a bit too small, so let's put a slider for this one. I don't want to get a bit more panels, so we're gonna play with the value. So let's go ch that threshold, yes, and slider. Okay, maybe 240. Get a bit more flat faces. Okay, so now among like most like other things, we're gonna do for loop per primitive again, but this part is a bit more complex. I think this part we can merge, and then this goes down. We should give this a name. So this was floor, this is external wall preparation. External wall, caps lock on, external wall prep. Let's just call it prep. Okay, now we're gonna take this from here, do another loop here, and then merge it back under, so we end up having some cool exteriors. Okay, so I'm gonna do an loop now. This is where is this? I have this one. Okay, so we can make another line like this, or just gonna make an object merge. It's just gonna be a bit more clear, less wires, and in fact I do have, if I select it, it's gonna show because I have the visibility for the dependency turned on. Okay, so let's go here. Now we're gonna create a little complex loop network. So drop by going for each primitive. And just hook it up, and then as soon as you turn it on, it's gonna fetch one. So now what I want is to cut this. I'll try to find a bit bigger one because it's gonna tell the story a bit better. A bit more squarish maybe. Is that a big one? We need a little bigger one. Okay, well, let's just go with the first one. It was searching too long otherwise. Okay, so just go into your loop. And now what I want is that I want to figure out my tangent for each one of these points, right? So I can use a polyframe for this, and I'm gonna remove the normal because I have it. I'm gonna create direction, first edge. So I want to visualize what this means, right? So I don't have an attribute visualizer called dir. So what you can do is that you can right click on this little guy and then say, I want to add a new scene visualizer. So you press plus and then a marker, and then we say the same attribute name as you see there, and which is this one, and then we can call it direction, and we don't want this to be, we want this to be a vector trail, and if I go here, so it's showing me, okay, so that's that going that way, that way, that way, that way, that way. So okay, so this is gonna work for me because now I can define, I know in which, like I have a how to put it in English. I have I know which direction. It's like my points are looking, my vectors are pointed towards the next point. So like 1 is looking at 2, 2 is looking at 3, 3 is looking at 0, and 0 is looking at 1. So this is gonna come very handy now. Why? Because we're gonna do some strange cutting by using clip. So that's a little complicated network. Just gonna open my file again because I was messing it around and then change some parameters. Because using the clip we can, so because we know where the origin is, right? So we need to be able to tell now first where the origin of this polygon is. So we're gonna use the centroid for this one. Then we need to be able to tell how much of a distance we want to shift it around. So that's what I'm gonna show you as well now. Where is it in my scene? Okay. Polyframe. So I also need to randomize this. Okay, but that will after. Let's do our first pass first. Okay, and then so where is my origin? So let's find the origin first. It's point attribute. We can get the, because we want to get these ones because we want to offset. We don't want to like the center. I'm gonna cut this a few times, so I need to get the position of, because I want to cut it. I want to align the center of my clip at 0 here. Sorry, here. Okay, so what does that mean? It means if I go a point, and it's gonna be keep all primitives. I want to keep them. I actually remove it. I just want to cut it. 0.0, 0, position, 0. Okay, so that's the, it's gonna give us 39.4011 of 0.0. So copy this, 1, 2. Okay, so now right now we are locked in. Our cutting corner is here, our origin. So if I move this distance around, it's gonna start cutting. So now the goal is to run this in a loop and cut this polygon iteratively, just going sideways and just to create a little paneling. Then there's quite a lot of ways to do this, but I think this one is a bit easy. I'd like to think so. So the direction, I already have direction that we create from the polyframe. So I'm just going to copy the first attribute like I did before, but instead of P, I'm going to change it to there. So that's Y component, Z component, Z component. Okay, so now I know that no matter how the polygon is aligned, I'm gonna have a proper vector for the cutting. So now we need to figure out a value that is, for example, for this specific polygon, it's gonna be 0 to 5 and a bit more than 5. So how do we determine this? Because every polygon in our scene is different. So we will need to calculate the edge A and edge B length for every time this loop is running. So I'm gonna add a little, basically 2 integers, 2 floats. So I'll go to edit parameter interface, clicking on that gearbox, and then we are gonna add a float here and another float. We're gonna call it edge A, edge A, HB, HB, HB. Okay, apply. So the formula goes, I need a distance, which is another expression, between point XYZ, and then this is from 0 to 0, so from 0 to 1, so that we're gonna do that here. So I'm gonna copy the expression and I'm gonna explain what it does. It's a bit long, but I mean, probably could have done it a bit more cleaner, but basically distance is a function that returns the distance given two vectors, and in this case it's point x, y, z of first point number here, of the point number 0, and then same thing for point number 1. So that's 0 and 1. So it's giving me a distance. So it says this unit is 5. Since this is aligned, since this polygon is vertical, so if you do a middle click here, I think it's gonna give the exact same thing, 5.18699. Yes, so the size, why? But we want to measure the distance, because if this was a polygon that was a bit more angled, the y max wouldn't give us the proper number. But now we know we actually have a distance that is going to work, even if this was angled geo. And then we're gonna do the same thing for point B. So we're now looking from 0 to 3. So from here to here we measured our distance as well. So one is 15.18. So we can now construct a formula that we know that it's going to stay. So we will never overshoot when we want to cut. So then I'm gonna paste this another one here. So what I want now is, actually I need to do this by hand. So but now I know that for each polygon it's gonna cut exactly from the same place, the same ratio. But I want to randomize that, and I want to run this a few times. In order to do that, in order to do this, I need to click on for each begin, and I'm creating a metadata. In its detailed attributes, it's going to give us some information. So iterations. I want to fetch that. I want to use that. So then I'm going to go to my distance, because I want to create a random number based on the iteration number. So with every iteration, it's going to give me a different result. So here now, we can type first. Let's get the current iteration number, which is where is my node? 1 second. I exposed it somewhere. Oh yes, I actually put another attribute, so let's do that. Because we link some attributes to some parameters and the codes become shorter, it's a bit easier to follow. So because that's an iteration, so it's an integer, so we go iteration, attribute name and the label. And then in here we can type detail, reference to the for each, which is this one, is this 3 metadata 1, 3 metadata 1, comma, it's string iteration, comma 0. That should return us like the current iteration number. That's fine. And now using this we can generate a little random number. So this value is always going to be between from 0 to 5, like 0 to max edge A and 0 to max edge B, and then distance. Okay. So we could now I did this with 2 cuts, but I think we could do that with 1 cut, with 1 clip, by switching the directions, but that's fine. Let's go simple, stupid for now. Okay, so that's gonna now cut as well. It's just that each cut is gonna be in a different ratio as opposed to the length. And now we're gonna create another one, another clip. We call it cut B. So again, the same thing as we have here. Copy. I think we could use the same one as well. Paste expression and channels. Okay, and then the distance is again very similar, but I am calling this time the lengths from the first clipping node. So it's like a channel referencing into a random. But here I was creating a random directly, getting the iteration here. Here I just have to say fetch the information from iteration from cut A node to create the value, and this is gonna create, and then the direction is again the same. It's the it's exactly the same. We're gonna use the same tangent information that we got from the polyframe, but I don't want that. I want like this. Okay, but except this time, no, that's actually it. That should be it. Let me see. Oh, and we need to keep all primitives. There is a little, I think there's an origin distance here. There's a little confusion here, I think, that I need to find out. Just a second, please. Well, and also we want to run this a certain amount of time, so iteration method is gonna be by count, and we're gonna feedback each iteration. The computer is calculating, and it's gonna fetch the feedback. So okay, so which means cut once, cut many times. Actually, I think it will be easier to show it like this. I'm trying to see if this is working properly, because it's not. It doesn't. I think I broke something, so that's what I'm trying to figure out. Because I thought I was supposed to cut it a bit more than this. Okay, let me pause it so I can check it again, and then we can continue the video. Okay, so we continue recording. I couldn't find anything wrong actually. That's we're just doing it that way. We're just cutting it. If I let me go auto detection for inputs. I'm gonna go one by one just to fetch input. Single pass. No. Undo. Go back to what it was. First one is gonna be fetch feedback. Last one is going to be feedback each merge or feedback is supposed to be feedback, otherwise it will duplicate by count. So I want 20 times. Okay, let's see if this is working one last time. Oops. 80, 90. Okay, so it's kind of adding a lot of lines, so it's kind of working. Let's go 50. Okay, so we have a lot of shapes now. So now I want to get out of this and then go clean. Oh, actually, there is a mistake here. My bad, because I want to run 2 loops in one master loop. So this is supposed to be working on only on one piece. So which means we need to do a for each on top, and this one is primitive again. For each primitive, we are gonna use this part. We're not ditching it. It's still very useful. Just gonna need to move it down. So after we bring in our, as we called it, external wall prep, let's pass it through a master for loop per primitive. Okay, so it's not doing anything at the moment, so I'm just going to bring this all the way down here. So we're just processing it, and then we're going to take this first one we made and we're going to bring it in here. So it's going to be a part of the loop. So it's going to cut each piece X amount of time. So that should produce a lot of cuts. So let's just bring this to 10 for now. Let's wait for the output. Okay, so that's what it did. Okay. If I zoom here, play with this, and now it's just cutting it randomly. Okay, that's what we want. After this polygon comes out from here, primitive, I want to clean up in case this cutting produces any I don't know, issues, overlaps, degenerate faces. And then what I want now is to cluster some of these cluster points. I don't need colored points. I want the clustered points, and I want a new attribute called, the output is temp cluster. And where is my loop? So I need to know which iteration I'm looping as well. So I'm going to create another metadata here. Okay, block begin, come here a little bit more. So now we need to fetch that information, and okay, seed. So I want cut a iteration, right? I plugged it in there. This one, clusters. So I took the, which one is this? Repeat and one. Repeat and one. Okay. Iterations. Okay, so I want to take the total number of iterations here, and then I want to paste it here. So it's gonna make a cluster for as many feedbacks as it has, but then I'm multiplying that by 2. I'm not sure why I multiplied that by 2. I guess just to get some more. So I guess because it's gonna do it, if it's 10 times, it's gonna create 40 clusters. What does that mean? 10 clusters. Okay, it's just creating random points, I guess. Now from points, I'm gonna promote this attribute, promote from points to primitives. It's gonna be temp clusters from points to primitives, first match. and then I'm going to convert the temp clusters to attribute wrangle, because I want to loop inside them as well. Attribute wrangle. So I'll create another primitive attribute. I'm going to convert this as temp clusters to string. So temp clusters equals ITO integer I at temp clusters. Okay, so now if we look at the name here, it's an integer. Here, oh, there's a typo. Integer to array. Temp clusters integer, which is running on there. Why are we erroring? Integer to array. I thought, am I running it wrong? Array to integer, integer to array. Yes. There's no attribute now. No, point primitive temp clusters. Temp clusters. Interesting. Temp clusters. Integer to array. Isn't this what we did here? I am confused now. Let's go back. Temp clusters. Temp clusters, that's an integer. I want this to be okay, I'll write it again. Attribute wrangle string at temp, let's call it temp for now, equals integer to array. There you go. At I at temp clusters semicolon. So that's working. Temp string. Okay, temp. It should just convert. That should be fine. Because it's the same name. Oh, okay. So we can't. Of course, we just give it a different name. Temp clusters. Now we'll put another for each based on primitive name this time, because we named them, and our name is this as temp clusters. So which means that we're gonna take this, and now we kind of like so this one did a lot of sections, and then we clustered them. I don't know if we can visualize by color. Yeah, we can. Colored points. So actually we can just put a color swap here. Get closer. Ramp. What is this point? No, let's go here. Temp clusters. Temp clusters, just getting it a bit more interesting. Basically, random from attribute, random from attribute, primitive. Well, this is a small shape, I guess, but it does create. Is it all same temp? No, it's temp clusters quite a lot. Temp clusters. Try to visualize. Visualize temp clusters. Here you go. I'll give it the name. It's not updating the color, but it is there. Maybe we'll visualize it outside because okay. So basically, I'm redistributing because it's like I cut it 3 times, but maybe I don't want so much, so I'm using a cluster points to cluster these primitives a bit closer to each other, a bit more random. Then I'm changing the name from promoting the name from point to primitive temp clusters, and here I'm converting it to a integer to a string attribute, so I can loop over them. And what I want is that as I loop over them, I want to remove, I just want to keep the outer shape. So I just get that. And then when I do that, it's kind of a bit more optimized. Well, I guess you can just run this a bit less to get a similar result, but it's just, I think, about randomization and maybe about how to run the loops in a loop. So the final thing I want to do is to put a primitive sock, plug it in, and then go to do transformation, turn it on, and then I want to scale each of these primitives by 0.99 by 1%. Then let the loop go through. Waiting. Okay, so we have some paneling happening now. I'm still not convinced with something which I have to find why. It's creating a lot of vertical lines. Because I should be getting more boxes as well, and that's the part that I am not sure what's going on, and I will have to find it. And I am very certain almost that it's about here. And why is my cut A? It's because my cut A is cutting correct, but my cut B is not cutting correct. Because my direction must be wrong. And that's what we're gonna find out. Because maybe that's what it is. Where's my direction? Zero minus 1 0 0 1. Oh, I think maybe that's what it is. Because I didn't change the point number. It's always 0 0, so it always gives the same direction. Yeah, so that's what we need to do. We get the next guy as our direction. We found the problem. Okay, now we got one straight line, so that should produce something very similar. Now we can try compiling this as well. We'll get there. We'll do a second pass for optimization. But this should give me now a much more interesting paneling shape. Okay, now it's working. All right, now it's working. So now we have some cool panels, quite random. Seems like it's gonna work fine. So let's merge it back with our rest of our. Let's call this maybe null here. No, we're gonna merge it here. No, we need to merge with the opposite of it. So basically, because we did like an area, so I need to do this needs to come here. Yeah, of course, because we need to do the reverse of this. My bad. So let's go to here. It needs to be still there. So less than 100, not more than threshold. Maybe it is now the opposite. No, a second, I need to. No, because we can't just merge them together because we need the opposite. So if I have this, I need to, this is area more than 100, this area less than 100. So it's gonna be, okay. We need to go from here, not from here, that's the problem. Okay, which is we're pulling in the wrong guy. We need to pull in measure. So basically, what I'm trying to do is, here I removed some, right? So then I need to copy this and paste here, but just reverse the condition to get the opposite. So that's where I can do the paneling, and then maybe I can copy this and paste it here. So if I slide one, the other one updates as well. So now that's gonna get the paneling. Therefore, we have some flat areas and we have some paneling. I guess we can do some more. Just to get a bit more shapes. I guess it needs to go down. Okay, let's get this much paneling. Then let's merge, let it cook. Let's have a close look on our new panels. Let's put a normal so it's a bit more clean to see. Hard surfaces. All right, cool. So we're getting somewhere. So it's a bit more interesting. Definitely a little bit more sci-fi feeling to it. And I think it's gonna do fine. Okay, so let's move forward. Now I don't need any more of these groups. I think we have a lot of attributes here. So group, delete pretty much everything except extrude front, which we should still have be inside a, oh, we don't have it because our boolean, well, it's clean, so let's clean it up. Pretty much, okay. And then let's put an attribute delete because we are already carrying too many attributes. So let's pretty much remove the color, remove the shape, remove X, remove Z, pretty much remove everything from here. Well, I guess just remove everything. Yeah, just gonna remove everything. Okay, so we removed all the attributes from here as well. Okay, I wonder if we should give it a little bit extrusion also. Oh, but it should, oh, we're missing something. I'm sorry, we are missing some chunks because we wanted to get the outside past. Maybe like this. Let me see my other scene to make sure that we are doing the right thing. Output front, do the extrusion, output front. I don't need the sides. Yeah, I don't need the sides. And then I do a boolean, subtract a minus b. That's correct. And then we go like this. Okay, that's correct. Because we want to have the outer shell, but not what's intersecting inside. So it's like that's the outside, that's empty inside, which is correct. Okay, creating a little normal to need this normal to be, I think, like 10. So it's a bit surfacey. Measure, merge. I think that's correct now. Okay, now it's correct. Now we have like a kind of shell. So when we put it, that's the part that's gonna be extruded from the building. Okay. I guess now we can go and start building our windows. So basically now if I want to show you where we're going with this, is that I merge this guy here, then if I merge this one, I guess that should still do. So we kind of made these black areas that is a bit more interesting than just flat walls. And then all this, most of this gray area is gonna disappear, and we're gonna have our windows. Like if I go like that, let it calculate real quick. Okay, so let's remove this. Okay, so kind of like some, I don't know, faceting. That's a bit more interesting faceting. Very futuristic. So now we're gonna start the windows. Let's organize here a bit better. And let's call this detailing maybe. And a little bit more space here. Like this. Let's select this guy. Let's call it paneling. Okay. And then null here. Alt panels. Okay. That's done as well. That's the black. Okay. So now we can start going for, this was another chunk. So also gonna put this in another network box. And we can mesh the colors too now, so as we're getting there. This one come here, line up. Okay, so paneling is gonna be different color. It's gonna be different color, just so we can identify them a bit better. This is important entrance part, so it gets a bit more hot. And hot colors usually and super dark colors I put for very crucial network options. Some green ones are usually, like if it's a source I go like blue, and if it's an output I go black. It's a good practice to get used to it. Let's bring this guy a bit down. Okay, so we're gonna go here now to start creating the windows. That's gonna be in the next video. I'm gonna stop it now.